Okay, so now we're going to do a complete enclosure from beginning to end, step by step. So assuming that it's already designed, you download the design in a ORD file, or you download it in a DXF file and you convert it here to an ORD file. We have the file, we clamp the material down, we have to enter the material thickness, we set the height. Typically you set the height, you bring it to touch the material and you go half a turn, lock it. Now set it to the beginning, this. Okay. Flood it. Cut. Okay, so now it's finished. So the first thing you want is to break the sharp edges, just to protect your fingers and also that things will lay flat well. So, especially here when you cut patterns like this, it's rough. You want to do this. Okay, so we have the parts cleaned up. There was a little error I made here in the file, and you can see there's an extra cut here which isn't needed. So that's a good opportunity to show how to repair mistakes with a spot welder, because sometimes you throw in an extra hole you didn't need, or misplaced hole or cut, so no need to scrap the part and wait another 7 minutes, but you can fix it with that. So the trick in fixing it, you always put an oversized piece, slightly oversized piece above the defect, and then you just melt it into the hole with a spot welder. So in this case, since there is an extra slot there, I just cut a strip which is a little bit wider than the slot, maybe by 0.5 millimeter or 1 millimeter. Set it fairly high setting because it's a big area. I'm going to melt it over a big area, so set it like a number 8. Okay. This is the extra little piece I cut out. So I lay it above the defect. That's it. It's melted in and fixed. So now the only thing left to do is cut it off, okay, and just touch up the corner, and that's it, no more defect. Okay, if you want to be a perfectionist, you can even sand a bit on top so it wouldn't show up after painting. So if you want to plug a hole, the plug doesn't even have to be round. You can cut a square plug, which is just a bit bigger than the hole, with a high current, and just flow in, melt and flow in. Okay. It just has to be a bit more metal than the hole, so it will always overfill it, so you can sand off. You always want to overfill, so you can sand off the excess, and if you can do a close-up here on this, you can see that it completely melts and fills the hole. Okay, the next thing we do, we put in the bends, and the thing to do when to put in the bends is two very, very important things. The first thing is you have to think through the order of bends, because some parts can only be bent in one order, otherwise they jam on the machine. So, for example, this thing, the edges have to be bent up, and then you have to have two bends here. So when you make these two bends here, the die has to fit between the bent up edges. Okay? Now the alternative, if you do it the other way, you can't bend it. If you bend these first and you get a U, you cannot come in and bend the lips. So you have to look at the part, take a deep breath, and figure out the order of bends. Now the second thing, which is very, very important, unless the part is symmetric, you have to bend it either on this side or this side, because you'll get a mirror image. And that is the most common mistake, that you look at it, bend it, and then you realize the mirror image, and there's a lot of straightening to do. So you think through, what do you want? You want a box that ends up like this, an on switch on this side, so you want to bend up this way. Okay, and we'll bend first the periphery, and then we'll make these two bends, because that's the only order you can bend this part. Okay? The width is more than the height, so there'll be no problem bending. You don't need any special tricks. These are 15 millimeters, so we bend the periphery first. Back to position. We set it to 15. Double check. Good. Double check the orientation. Good. Now, okay, so we bend these bends first. Now, before I decide what should I bend first, should I bend the two long lines first or the short ones first? So I look which tooling I have, because once I bend one pair, I need a tool which fits in between. Okay? So if I bend those edges first, I need a tool this long to fit in between, and I actually have one a bit shorter. If I bend these first, I need a tool this long, and I have one here which is a bit too long, so it's no good. So so I'm better off actually bending the short ones first, because this tool is closer to the length of the unit. Okay, so we'll bend short ones first. It is right angle, it's good. Now, good. Okay. Now, I'll bend the two long ones, and for that I have to segment, open here the segmentation. Do it like this. Do this like this. Move this over. Okay, and this is a little bit too short, but I can add a segment like this, then it'll be close enough. Yeah, that's good. A little bit closer. Now you don't have to worry about this little gap. It will bend it nicely in spite of the little gap, and you can always go over it twice. You can move it a bit and go over it twice in this place. So you try to spread those as much as it will allow you to get a more accurate rest point. So this will go in like this. Oops. That's almost exact, so you have to do it carefully. This. Check, need a bit more pressure, because it's a wider strip. It actually could use a bit more pressure. Okay. Yeah, that's good. This. Okay, now I can put in these bends, which I needed here. And again, I don't have the right width. I'll have to make it up. And it doesn't have to be accurate. As you can see here, although this had a gap, if you look at the bend, you don't notice any problem. I can feel it, just a minute thing here, that if I'm a perfectionist, I can iron out on another section. Say, if I wanted to, or I can just reverse it, for that matter. It doesn't fit, so if I wanted to, I could iron out this minute signature by putting it here, but barely perceptible. Okay, now I have to bend those. Okay, so I have to set up some segments. Okay, but now before I bend it up, I noticed that I have here two riv nuts or two threads insert I need to put in. It's much easier to spot weld them in before I bend it. Although I could do it, actually it will fit into the spot welder even when bent, but it's much easier this way. So at this point I'll stop, weld the two nuts and finish bending. One. Good. So now we'll bend these two bends and we are done. Now if it's not perfectly square, you can still flex it a bit like this. And now we have to bend the cover to exactly fit over it. Now when you bend the cover, and if you want it to fit well, you have to allow for the material thickness and the bend radius and 1,000 other things which are too complicated. So what you do is, it's much simpler. When you cut the cover, you always cut a test strip exactly the same width as the cover. Okay, so it's cut on the same sheet. Now you calculate on the CAD, and some programs will exactly calculate it for you. For example, like SolidWorks sheet metal option will calculate for you and tell you where to put the bends. So you put in the number they tell you and do a test bend and see if it fits, and then you adjust the number. And this way you only waste one strip instead of wasting a whole cover. So the calculation said 92. Okay, and then you fit it over this, and it's close but not perfect, because actually would be too tight a fit. Okay. And that's the whole purpose of this. You look at the error. The error is actually like 2 millimeters almost. So you make it 91 on each side. And if you're not sure, you can use the same strip. Test it again. A bit tight, but that's because this is not really a 90-degree bend. You can see it's a bit open. This really should be squeezed in a bit, otherwise the fit wouldn't look nice. So, because otherwise the cover will leave a little gap here. So just to make the cover fit more perfectly, since this was not quite 90 degrees, I'll just push it down a little bit. You never hammer on the sheet metal directly, otherwise it'll make dents. You always put some spreader like this. And now we check how the cover will fit. Yeah. And now the cover fits perfectly and there is no gap here. Now another thing you always do with sheet metal, you never make the cover reach out this much to the end, because then you get a sharp edge. You always recess the cover a couple of millimeters so you get the rounded edge of the bend, and then you get the cover. So this way there's no sharp edge. The problem with sharp edge is not only cutting yourself, the problem is the paint will always chip from a sharp edge, so it will look ugly. So you always recess it, so if you hit something, it hits it on the rounded corner. So now we know the cover is good. Now we bend the cover. Again, it's left hand and the right hand. You stop and think. Okay, so yeah, looks good. Okay, and now if we look here, cover is fitting this way and it's supposed to fit perfectly. It does. And it's supposed to be a bit shorter, and it does. And you can see here you get the right edge. Now this is a bit flimsy. As you can see, it's not exact, and so a good idea is to adjust it exactly to be a right angle and spot weld a couple of braces in, because you got this and nothing to do with it anyway. So you cut it into 4 pieces. Okay, you set up from number 4 or even number 3, because we already did this test before with the thickness of metal. We know the thickness. Now what you do is you put in 4 braces like this, but you weld only one side because you have to adjust it for right angles. So you put in the braces underneath, and these braces are not so important because the cover will hold it anyway, but just if you want the extra stiffness, put it in. So the next step is, we welded the braces at one side, so the next step is to bend it exactly to a square against a square and weld the other side of each brace. Okay, and now if we try the cover, everything should line up now. So this is the front of the box. Cover fits beautifully. Okay, the screws line up, everything is good. Now a couple of things to note. First, to make the cover not rattle, right? It's a good idea to always bias the cover a little bit too tight. So like this. Now, yeah, so now the cover is pressed against this. Now, a couple of things I want to point out here before we continue, because you want to take advantage of all the features of the water jet. So for example, when you cut a hole for a toggle switch, you cut the little key, and I'll put something white behind it so you can see. I don't know if you can see that this has a little key. And this key lines up with the slot in the switch. The same thing when you plug in the cord relief, the hole at the back is double D-shaped, it's not round. Because most of the things you buy have a feature against rotation, like all the industrial switches, everything has a key. So when you cut with a water jet, you always cut in the keys. Another thing, you can take advantage of the water jet. If you are not sure about holes, whether you need them or not, you can cut with the water jet knockouts. Knockouts are the same like electrical boxes, which are holes which are not complete, and you can punch them out later. It's much easier to punch out than to start drilling, especially when the box is assembled. And the way you do a knockout, say if I wanted a second hole like this, a knockout, I would leave 2 tabs holding the plug in place, so I can easily knock it out. For example, if you zoom in here, has a spare hole just in case I need a knockout. Okay, that's important. A third thing to take advantage is when you do the part, you think, are there going to be any little brackets I need inside? Clamps for cables, little L's, brackets. cut them all out from the same sheet, and then they all get painted together and everything fits. So think of all the little bits and pieces you'll need. So for example, when this was cut out, I already knew I'll need a clamp for the cable. So every little piece you'll need inside was already laid out on the same sheet. Okay. Now, a second thing to keep in mind when you design for water jet is all the holes in one plane will be perfectly registered, because the machine is accurate about a tenth of a millimeter, so the holes will be perfectly registered. The moment you bend, you lose the registration, because like the distance between these two holes is much less accurate, because it depends on how square is the bend, and it depends on the exact material which is used up in the bend. So it's very difficult to get registration across bend lines. Okay, so say if I could, would have been better to make this box in a different way, that actually the cover, there will, instead of two holes across bends, there will be two bends this way and say holes this way or holes this way, which the distance cannot be changed by bending. But here there was no choice, because I wanted the cover this way, so I had to suffer with the holes across bend lines, which the tolerance is less. And indeed, I would like it a little bit longer. Okay. Now, another thing to keep in mind, when you bend, if a hole is very close to the bend line, it will become very ugly, because this is about as close you want to keep it to a bend line. Because imagine if this edge was 3 millimeter instead of 10 millimeter, it will twist and distort instead of bending nicely. And especially true for a round hole. If you take a round hole, put it near a bend line, it will get distorted out of round. So if you absolutely have to put a round hole or a hole at a bend line, make it like a U in a flat, where the flat lines up with the bend line, because the flat already stays flat after you bend. But don't make a round hole touching a bend line, because it'll distort. So anything, ideally you want to stay 10 millimeter away with any openings from a bend line. Here actually worked okay. Same reason here, if you want an opening, I left a good 15 millimeter to the bend line to avoid any distortion. Okay, so that's about all what you need. Now, then you have to go and put in all the studs and nuts you need inside before you sandblast and paint. Okay, so let's say we need here 2 nuts and 2 studs. I'll put them in. Okay. So, these are done a setting of 8. Remember, the nuts and stud always take a much longer duration than just a weld, because the area is larger. So 1, 2, then also remember that after you paint, you can no longer spot weld, because the paint is an insulator. Even if you scrape off the paint, you still need contact from the other side. So better think twice. Okay. So what I did, the places I needed studs, okay, I'm using standard round head screws as studs. So what I did is I drilled a hole with a water jet so I can feel where the head is. Okay, this way, because it doesn't have this little sharp tip, so I need to make a bigger hole so I can just by feel know where it fits. Like this, I can feel a click where the hole falls in. I can't overstress the importance of captive hardware in electronic assemblies, because the more captive the hardware is, the less chances of a screw falling and shorting out the whole circuit board. So everything which could be captive, you have to think ahead and put it in. Okay, so we put in all the captive hardware, everything fits. Okay, next step is sandblasting. Okay, everything fits, so that's about the right time to turn on the oven. Okay. And the next thing is sandblasting. Okay. So the next step is just make sure everything is ready for paint. So any place you don't like paint on, you have to cover either with a silicone rubber tube or mask with Kapton tape, which can take the temperature. So I just don't want paint on these two studs. And sometimes you want to cover them even before sandblasting if you don't want them to roughen up. The rest, the nuts, you don't worry because you have to go through the threads anyway to clean them out, so you don't worry about paint. You make a couple of hangers to hang the part, and the same hanger will be used to hang it inside. So you hang it in a way, you want to hang it in a way that you don't see any signature from the hanger. So what I do is I do it like this, so now the part where the hanger is touching is not, it's invisible, and make it shorter like this. That is one. Interestingly, you cannot reuse the hangers because the hangers are supposed to ground it. Once they get powder coated, you cannot reuse them. So this one we can get like this, and again like this. Okay, and we get everything ready here to put it in the oven. Gloves, everything. Okay, we'll paint it white. Now, the nominal procedure for painting is to put in the oven for about 5 minutes at 235 Celsius, which is about 380 F. After 5 minutes, the paint flowed, and then you're supposed to drop the temperature from 230 to 190 C, which will be about less than 350 F, and leave it for another 15 minutes. So the total cycle is 20 minutes. If you don't want to bother, you can leave it the whole cycle at 230 or 235, but the paint will yellow a little bit, which is not all bad because white turns into a very light beige, which is actually quite beautiful. So the color becomes one shade warmer. Since for most stuff we are not into color science a lot, so you can just put it in at 235 C, leave it for 20 minutes, and that's it. The reason why you need to leave it after it flowed is it has to cross-link. The hardness comes from the chemical cross-linking, especially on this one, which is epoxy. And if you don't leave it a full term, it will look the same, but the paint will be soft. Okay, so now for inside corners, you may want to reduce the voltage, so the electrostatic field has less shielding. So first we'll start with the inside corners, maybe at 15 kilovolts. Okay, then we can do the rest, maybe anything from 20 to 50 kilovolt is fine. The reason why there's so much overspray here is because everything here is metal, which it shouldn't be, because that's actually a welding corner. So everything is metal, so the electrostatic particles are attracted to everything, not just to the workpiece. If you have a proper enclosure made of non-metal, all the powder will go just where it should. This I have to backside a bit. Okay. Turn it over again, in a proper enclosure, this would be hanging on a rotating shaft, so it will slowly rotate as you spray. You wouldn't have to turn it around. Okay, good enough. I just want to make sure powder reached below. Yeah. Have one look around, see if it reached. Oh, this. Now we hang it in the oven. As I said, in this case, we just leave it at 235 or 380 F, roughly, for 20 minutes, and that's done. If you touched it by mistake, the powder will come off right away, so you just overspray it with a bit of powder. Even after it's painted, if there's a defect, you can overspray and hang it back in the oven. Okay. Okay, this whole apparent mess cleans up instantly with a vacuum cleaner. And if you cool it down here for a minute. So you can see it's off-white now. It went one shadow towards beige because I didn't drop the temperature, but that's okay because who cares? Okay, so now it's all cooled down, out of the oven, everything ready. Last step is you take off these protectors for the threads. As you remember, these protectors have to be silicone rubber or a Kapton tape, otherwise they'll fuse and be trouble. And one last step to go over the threads, because the threads are dirty both from the spot welding and the painting. So you just have to go over them with a tap, set the torque so it doesn't break the tap if something bad happens. Good. Okay, now put in the mounting screws. Okay, and try the cover for fit. The cover goes like this and then like this. Okay, everything fits. And main thing is you can slide it off without removing the screws. I cannot overemphasize how important it is to make everything with keyholes and slots and captive hardware, because if you spend all your life in R&D, you'll spend about 1 year of your life taking screws out of covers. So if you do it in slots, it's the same as extending your life by the same amount as health food plus exercise extends your life. And it's much simpler. Okay, so here it is, ready to go.